Hey, welcome back. So in this lecture, let's get into our third step, that is running your FreeRTOS application and getting the recorder memory dump onto the file. Okay, great. So we have in the previous lecture, we have successfully compiled this code, isn't it? So now let's download this code into our hardware, that is Arduino Duo board, and let's enter into the debugging mode. Okay, so for that, go to debug and click on start debugging. Okay, so this will also download your latest code onto the flash memory of your board. Okay, it is saying please select a connected tool and interface and try again. All right, so that means you have to select your debugger, that is Atmel IC, and the interface is of course the JTAG, then file, save all, then click debug, start debugging. Okay, so this will also download the code into your hardware. Okay, all right, so we are now into the debug mode. So now what you have to do is you have to run, and after that you have to halt. Okay, so we have already called the trace init and trace start, isn't it? So once you call these APIs, they will start recording your FreeRTOS application execution events. Okay, all right, so now let's run. Okay, and after some time let's halt. Okay, so we are currently halted here, that's fine. So now go to tools and open a memory logger application. So if you don't see this option, then the memory logger would not have installed in your Atmel Studio. So for that you have to go to external tools over here, extensions and updates over here, and here search for memory. Okay, then it will show the memory logger extension to your Atmel Studio. In my case it is already installed, so that's why it is showing an install option. So but for you it should show the install option, so just install this extension. Okay, great. So now go to tools and open the memory logger application, and here, so now here click on memory. Okay, so that is of course the base. Then you have to give the start and end of the memory address, okay, between which you want to save the memory. Okay, first we have to find out what is the start address. The start address is nothing but the start of your recorder data structure in the RAM memory. Okay, and the end is calculated by adding the size of your recorder data structure to the start address. Okay, so that means now we have to find out what is the start address of the recorded data structure. Okay, for that you have to go into the output files which are generated during your compilation. In that you have to open the map file. Okay, FreeRTOS test_map, okay, here search for the word recorder. So that is this recorded data. Okay, search. Here you can see this is the address from where this data structure, this is nothing but just an array. Okay, so this recorded data structure, that's an array, starts from this location in the RAM. Okay, so that's why we have to copy this address. Just copy this and paste to some notepad. Okay, all right, so after that this is the size, so just copy that, paste here. So this is the start address of the recorder data. Okay, and this is the size. All right, and when you add those two you will get the end address. So end address, so that turns out to be 2007 C454. Okay, all right, so now let's copy this address and go to our Atmel Studio, open the memory logger, Okay, so give your start address here and the end address will be this one, right? So now let's save this memory dump into the file. So for that you have to give a file name. Okay, so the output file name, you have to mention the folder here. Okay, so let's do it in this path only. Okay, so this is our project path, isn't it? So let's go to here and create a new folder called memdump. Okay, you can create wherever you want, no problem. Okay, here I will give a name like test. Okay, just give a name test. So this is with the extension of hex. Okay, it will take by default. Save. Okay, so now click on this big button, that is save. Okay, now the memory contents between these addresses is stored into this file. Okay, so you can open with a notepad over here. So just click on show in viewer. Okay, here you can see this is our test.hex, which is having this memory dump from the RAM. Okay, so this is a memory dump between these addresses. Okay, so now this test.hex you have to give as an input to the Tracelyzer software. All right, so now let's do that. So go to your Atmos Studio, just close this. Okay, and open. Now you can come out of the debugging. Okay, so no problem, because we have already saved the RAM contents. Now you can even reset your board, no problem, we have already saved. Okay, so now go to tools and open FreeRTOS plus trace. Click on free edition. Great, so now what's our path of memory dump file? I saved here, memory dump folder. Okay, just copy this path and go to file, click on open. Okay, so then give this path, select this file and open. Great, so this is the trace of your FreeRTOS task execution. So you can zoom here by using zoom in option. So this is the execution of two tasks alternatively, right? So this application actually consists of two tasks, okay, so which will be executing alternatively. So I will explain the task creation, scheduling, execution, all in the later videos. Okay, so this section basically focused on how to make the Tracelyzer software up and running. Okay, that's it. So our application actually it had two tasks. Okay, so these are the two tasks which are executing alternatively. Okay, so this red bar corresponds to task 1 and this yellow bar corresponds to task 1 and this corresponds to the idle task. Okay, so but in this case it is not highlighted because that's not executing. Okay, so don't worry about all these details, we'll learn later. So by this trace you can determine lot of details, like for how many milliseconds the task 1 is running, the task 2 is running, everything you can find out. Suppose if I select this one, okay, here at the bottom you can see this task actually ran from 3.39 milliseconds to 4.38 milliseconds, right? So like that. So you can, and after that it got preempted over here. Okay, so after that the task 2 got preempted over here, and then task 1 scheduled to run, and task 1 is also identical to task 2, so that's why this also takes the same amount like the task 2, so both will share the equal CPU time. All right, suppose if I click on this one, okay, here you can see at the right hand side it is saying that this is task 1, that is name of the task is task 1, and it actually started at 3.3 second and ended at 4.3 seconds. Okay, and at this duration, okay, it consumed around 50% of the CPU time. Alright, so all these details I will cover whenever I do pre-RTOS exercises. So after every exercises, we will get the trace and we will analyze the behavior of the application execution. Great. So I will see you in the next section. Bye.